Hi students, so in the last video we have seen the mechanism of evolution of hydrogen. Now we want to see the mechanism of wet corrosion by oxygen absorption. This type of mechanism generally occurs when the environment is alkaline or neutral. Now let's understand what this mechanism speaks about. Now in this case, suppose we have a tank which is surrounded by an electrolyte, and this surface, what is called as the rust, is formed. Clear? Now suppose if this rust film breaks in between, okay, so if there is no rust formation over here, then what will happen? This metal surface which is there will be exposed to the environment, right? So this smaller part will be acting as anode, and the remaining part of the metal surface, what we will say, that will act as cathode. So this small part which is acting as anode, as we can say, small anodic area caused by the cracks in the oxide film where corrosion occurs. So in this small part, that is anode, the reaction which is going to take place is Fe gives you Fe plus 2 electrons. So what will happen now? This part will act as anode and it will form Fe ions and electrons. Right? Now these electrons, as you can see by the upward arrow, the electrons move upwards, and these electrons are absorbed by the oxygen to form hydroxyl ions. Okay, so the environment, why we say the name of this mechanism of oxygen absorption, and this is satisfied by this reaction, that is the oxygen reacts with the electrons to form hydroxyl ions. Now these Fe ions which are present and the hydroxyl ion combine together to give you what is called as the rust formation takes place. Okay, so when the rust formation starts forming, it will cover the whole surface area with the rust, and then the corrosion is prevented. So what are the reactions at the anode? As we have studied, the anode is the smaller part is called as the anode. So at anode, the Fe metal which is there, it starts giving out Fe ions and electrons, and this process, let's see, I'll just zoom to the reaction, and this process is called as oxidation. At cathode, what happens? The released electrons flow from anode to cathode through iron metal. Now what happens then? These electrons react with the water of the environment and oxygen to form hydroxyl ions. That process is called as reduction. So what is at the anode? Fe ions are formed, and at the cathode hydroxyl ions are formed. So this Fe plus 2 OH minus, this combine to give you what is called as the ferrous hydroxide. So this ferrous hydroxide is not the actually rust. If oxygen is in excess, then further reaction take place is that the ferrous hydroxide is further oxidized to form ferric hydroxide. And this ferric hydroxide, how do you get the reaction? See, we have ferrous hydroxide reacts with oxygen and water to give you what is 4FeOH thrice. This is called as the yellow rust. Okay, so because of the formation of this yellow rust, what is called as corrosion takes place, and this film of rust gets completed. So this is how the mechanism of corrosion takes place when there is a crack formation is there, or we can say when the stable film breaks in between, then the penetration of the oxygen of the environment takes place where we have the aqueous neutral solution of electrolyte is present, then the corrosion takes place by this method. So students, now further we are going to study what are the various types of corrosion. the first type of corrosion, which is called as concentration cell corrosion. Now in the concentration, when we say about the concentration can be of the electrolyte or the difference in concentration can be because of the atmosphere. As we know that a corrosion takes place when there is a difference in oxidation potential, right? So this concentration cell is classified into two. The first one is called as an electrolyte of different concentration and the second is called as differential aeration. Now let's see this, the first case, that is when we have electrolyte of different concentration. We have studied this in the chapter that is of electrochemistry, where we have studied types of electrochemical cells. Now what this diagram tells you, concentration cell, in the concentration cell corrosion we have two different we have electrodes of the same metal. That is, when we have electrodes of the same metal, as in this figure you can see it is made up of copper. So I have anode which is made up of copper and have cathode which is made up of copper, and they are dipped in different electrolyte solution concentration. That is, anode, it is dipped in copper sulfate solution which is dilute, okay, and cathode is dipped in a copper sulfate solution which is concentrated. So when we have both electrodes are same, of the same metal, there is no different electrodes, we have the same metal electrodes are dipped in different electrolyte solution, one is dilute and one is concentrated, then what will happen, the electrode which is dipped in the dilute solution will act as anode and it will give out ions and electrons. The electrons move here and they are absorbed by the cathode and it gets protected, right? So this is how, when we have different concentration solutions, the corrosion occurs. The second one what we are going to study about is called as differential aeration. Now in the differential aeration we will see with the diagram. Now suppose if I have filled a container with water, okay, and here you don't have two electrodes, I have only one electrode, that is zinc rod, and this zinc rod I have dipped in zinc chloride solution. So we can consider this as a half cell, right? So we have only one metal rod and it is dipped in the electrolyte solution, that is zinc rod is dipped in zinc chloride solution. So in this case, will the corrosion take place? Now let's see how the corrosion takes place over here. So here we don't have different electrodes. So difference in oxidation is not because of the difference in the potential of the metals. Now what is the difference over here? If I generally we have seen, suppose if we have any metal piece and we dipped in water, which portion the corrosion starts? It is the portion which is above the water or which is inside the water. So we generally know the part which is immersed in the water is acting as anode and the corrosion will start from here. Now why this takes place is because, as we can see, where is more oxygen part? Now the surface which is above this water line, this black color line, this surface, or this is the interface between the atmosphere and the water, is called as the water line. So above this part, as you can see, this is called as more oxygenated part which acts as cathode. So rusting do not take place over here on the top because this is acting as cathode. Whereas the lower part, where we have in the water we have dissolved oxygen which is less as compared to the outer atmospheric part. So here we have less oxygenated part. So it's written over here, less oxygenated part. This part will act as anode and the reaction will taking place over here is that zinc will form zinc ions and electrons. Okay. So this electrons are further moves up over here. So the reaction is, it passes through this water. So the reaction is half O2 plus water plus 2 electrons forms 2 hydroxyl ions. So what is the final output. At anode we have zinc ions formed, and at cathode we have hydroxyl ions formed. So corrosion takes place at the anode and the cathode gets protected. So when this question is asked in the examination, explain the concentration cell corrosion, then you have to explain the first, that is difference in electrolyte concentration that we have seen in the previous slide. With the diagram you have to explain. Also then you have to explain about the differential aeration by giving this diagram, reactions and explanations. This is one of the examples which we already while going on the Vashi bridge we can see such type of corrosion takes place, where we can see this metal rod is dipped, is immersed in the water. So the corrosion takes place at the waterline portion over here. Okay, and therefore research for prevention of corrosion is a must nowadays. So the second type of corrosion that we are going to study is called as galvanic corrosion or bimetallic corrosion. You have already studied galvanic corrosion right from your 12th and the last chapter that we have studied of concepts of electrochemistry. So as we know, the galvanic corrosion, that is when we have two metals electrode of different metals. Okay, then one will act as anode and one will act as cathode depending upon the electrode potential. So this slide tells you that this is a brass screw, okay, and the nut which is there, right, we have a nut bolt the screws have. So this part is made up of mild steel nut, and this part is called as this is made up of brass screw. So what happens now, this part which is made up of mild steel, it acts as anode and therefore it undergoes corrosion, and the other metal acts as cathode and therefore it is protected. So now let's see how this galvanic corrosion principle works out. So here we can see in this diagram we have two electrodes, one is zinc and one is copper, and they are dipped in the electrolyte solution which is not shown right now in this figure. So zinc is dipped in zinc sulfate, copper in copper sulfate solution, where that is talking about the galvanic cell, and we have the electrolytes over here. So zinc will act as anode, it will give away the electrons. These electrons are absorbed by the cathode and therefore the cathode is protected. So this we have already studied previously also, so it's a recap of galvanic corrosion. This is the example of the speed boats. As we know, the speed boats which are used in the oceans, and we can see the parts which are submerged into the water. This kind of corrosion can take place. The next we are going to study about, which is called as pitting corrosion. What is pitting corrosion? We all of you know the pits, right? We can say that is a pits where we have the rough surface which is there. Okay, so suppose if we have a metal which is a smooth surface and the other one is having a rough surface, then where the corrosion will take place? Obviously on the uneven surface, that is the rough surface, where there is a large amount. So when on a metal surface where we have pits, okay, then there is a tendency of accumulation of dirt, oil and also water. So where we have pits, that portion has a tendency for acting as anode, and the remaining part, okay, which is passive, it acts as cathode. And this is a metal that is iron. So what will be the reaction? Now you will be quite familiar with the reaction. What will be the reaction over here? This iron will form Fe plus 2 electrons. These 2 electrons will move up, and then further it will react with half O2 plus water plus 2 electrons to form hydroxyl ions. Now this is the same like the mechanism of absorption of oxygen that we have studied previously. So we have Fe ions and hydroxyl ions. So what will happen? Fe ions will react with hydroxyl ions to form ferrous hydroxide. In the excess of oxygen, the ferrous hydroxide gets converted to ferric hydroxide, and this, the pits will get corroded. This whole metal gets corroded. So few of the examples, yeah, these are the examples which we have seen. As you can see, this is the kitchen sink, and because of the small pits is there, the corrosion can take place. Here you can see this is generally the stand which we see near the swimming pool, okay, and such type of small pits occurs and can lead to a corrosion, and therefore this material gets spoiled. Okay, now the next corrosion type of corrosion that we are going to study is called as stress corrosion. Obviously when we have lot amount of stress, then visually we get disturbed, and it reflects with your behavior, okay, with others. So similarly, the metals also undergo stress. Now when do the metals undergo stress? See, if we are going to make any machine parts, that time large amount of heating and different processes like forging, machining takes place, and that time the metal bears a large amount of stress. Okay, so because of the manufacturing, when the metal bears stress, and also if the environment, if lot amount of water is there or acidic environment is there, then obviously the corrosion enhances, right? So what is the stress corrosion? Stress corrosion is defined as it is the combined effect of static tensile stress. What do you understand by static tensile stress? That is, at the same position you are applying a longer amount of stress is applied. The other one is called as a dynamic. Now what do you understand by dynamic? It is moving. For some part it is there for a shorter time, then it spreads on the other one. So that is called as a dynamic stress. That will not affect a lot. But if we have a static tensile strength, suppose if a heavy person is sitting on a bench for around maybe 10-20 hours, then that is called as the static tensile strength, and that can result in the breaking of that bench. So when we have static tensile strength and also the corrosive environment of the metal, then what is called as the stress corrosion occurs. So it is characterized by a highly localized attack occurring when overall corrosion is negligible. So generally the corrosion should not take place when we have conditions of these two, that is we have static tensile stress and corrosive environment, then the corrosion can take place. Now, so for stress corrosion to occur, generally two things, as I have said earlier, presence of tensile stress and a specific corrosive environment are necessary. So as you can see in this diagram, suppose if I have this metal which is bent, okay, there is a bend in this metal, then where this metal will bear more amount of stress, which will be the stress part? Yeah, this part which has a bend, okay, that will have a stress and that will act as anode, and the remaining part where the stress is less will act as cathode. So a bar that was bent and not treated to remove residual stresses will have regions of stress as indicated. So these are the marked stress which is indicated in a different color. These areas of increased stress will be anodic to the rest of the bar and will corrode. So this part will act as anode, will undergo corrosion, will start. Okay. So outside of the bar will have residual tensile stresses because this was the side which was required to stretch to accommodate the bend. So this remaining part will act as cathode. So generally the stress corrosion, we have one of the example is in season cracking, which takes place when we have corrosion environment which matters